Hey guys, I'm here today to unfortunately discuss some points of trouble and frustration that I've been having with my MPP Solar LV6548 inverters. I would much rather be making videos of positivity, however at this point I'm just kind of fed up with some of the hardware designs and way the hardware is being supported. Coming up here in April, I'm actually going to be pulling these out of service and replacing them with a brand new pair of EG4's 6000 XP inverters from Lux Power. I purchased those from Current Connected back in December during the pre-order, and I'm very excited to see what they can do and get them installed. So I'm running this pair of inverters behind me in a split phase configuration. This is completely off grid, there is no grid input, there's no generator input, and they've been working very well. I've thrown all sorts of loads at them in terms of the size of the load, whether it's inductive or not, and there's only one time that I can think of that I've had a failure with these inverters, and that was due to a thermal shutdown, because the doors of the container were closed and it overheated. And that is an environmental problem with my setup, not a problem with the inverter. So you can see that they are very reliable. The biggest problem I have with these inverters are the design specifications and the apparent lack of thought or any reasoning that has gone into it. These inverters each have two MPPT solar charge controllers with a maximum voltage open circuit of 250 volts and a maximum operating current of 18 amps. The 250 volt rating heavily restricts the amount of panels you can actually connect to this, especially in the winter since I'm in the Northeast, because you have to leave in some headroom for the increased open circuit voltage in colder temperatures. Now they seem to have figured this out along the way. EG4 had a very similar inverter with a 500 volt MPPT charge controller. Shortly thereafter, MPP Solar released their newer LV6548V, and that featured a 390 volt open circuit charge controller. Now that's all well and good, it's an increase in voltage, until you find out that that changed the idle consumption of the inverter from 65 watts to 110 watts. 110 watts for one inverter. I've got two inverters, so that's 220 watts of power being consumed when the inverters are at idle. And by the way, the LV6548 is not compatible with the LV6548V. Now I published a video in early 2023 discussing these inverters. I actually did a full review of them. MPP Solar had contacted me shortly after to get some clarification as to how I did their testing, saying that it didn't match their lab testing. At the time they were advertising the V version as having an idle consumption of less than 75 watts. I then explained to them around the March 23 timeframe what I had done and how I had run this test, and they said they were going to go back and do some additional testing to see if they could recreate it. There might be a new firmware version, you know, things like that. So I followed up in April 23, May 23, and I still had no updates. So it's now February of 2024 and I still haven't heard any updates. Of course, I haven't asked since last May. However, I do see they've removed the 75 watt idle consumption claim from the marketing material of their LV6548V. Now let's just set that one aside for now. The next issue is communication protocols. This LV6548 was advertised as having CAN bus support. It turns out the only way they have CAN bus support is using two proprietary protocols, either Wico or Solatro, both of which are closed source, and neither company will give you the protocol specifications so you can design something to use it. So that protocol is completely useless. At least in the United States, I've not heard or seen anyone selling either Wico or Solatro batteries. I've not seen it, so what is the purpose of that protocol? Perhaps in other countries, I know Voltronics does a lot in like South Africa. You know, those areas might have these batteries, but if you're selling this worldwide, add a more standard protocol. So now in early 2023, they had released a firmware update that you could apply to your inverters, which would enable a more generic CAN-based protocol referred to as LIA. And they also released a protocol documentation so you could write integrations against it. That's great, right? But wait, it only works on the LV6548 and the LV6548V that were produced on or after Q4 of 2022. Mine came before that. Now why is that? Well, apparently they made some sort of secret hardware change in there. So there are two versions of the LV6548, one that was before Q4 of 2022 and one that was after Q4 of 2022. So if you bought some of these early on and then you go out to find another LV6548, first of all, you don't know which one the company's selling unless you actually ask them, hey, which date was your inverter manufactured in? If you can get a correct answer out of them. If you want to find one to pair with an existing system, you're out of luck. Not to mention, it's been very difficult for me to actually find somebody carrying the LV6548 produced after Q4 of 2022. And I can't even tell you how many versions exist, because supposedly an LV6548V does exist from before Q4 of 2022, though I've not personally seen one. I'm very frustrated at this point because I've spent a lot of my time trying to get these inverters to talk over CAN bus by reverse engineering the two provided protocols, and now they release an update that I can't use on these inverters. I bought 2 of these inverters at full price. I bought 2 of the LV6548s at full price. I can't use those because they have 110 watts of idle per inverter, and I refuse to run those inverters. So at this point, I've become very comfortable with flashing the firmware on these inverters, and I got the genius idea of, you know, what'll happen if I load the new firmware on the old inverter? Because I could always roll it back, right? If it doesn't work, I can roll it back. And this is where I proceeded to load that firmware, and that was wrong, and that was possibly one of the worst decisions I've made with these inverters thus far. So now I have one inverter here. The one in the far back is running the V45 original firmware, and this one in the front here is running the V69 firmware. They still run, as you can see, they're still charging and powering loads, but something is very, very broken with them. The inverter running the new firmware will now talk LIA over CAN bus. It talks the protocol. It just will not acknowledge commands that are sent to it. So if I send it the inverter discharge shutdown command, which was new in LIA, it does not respond, and it actually locks up the display. And the only way to fix this once it's locked up is to power down completely. Disconnect the PV, the batteries, and power it down completely, and then restart it. Now, sometimes it even does this lockup problem by simply plugging in the communications cable, not even sending any commands to it. Of course, it's probably doing handshakes at that time, so maybe something there is breaking it, but that's besides the point. It seems there is a communications disconnect that's occurred between the front panel display and the control board inside the inverter. I cannot get the firmware to roll back it by any means. I've tried and tried and tried, and I've tried the USB drive method, I've tried the typical flashing method over RS-232. The problem is it connects to the inverter and then it says it's starting to write blocks and it just stays at 0 blocks written, and then it eventually times out. So I reached out to MPP Solar support and I said, hey, I did this, it was a mistake. You know, if I make a mistake, I'm more than happy to admit that mistake and take necessary steps to fix it. I'm not going to say, you should fix this because it's not working. I said, hey, I made this mistake, I know it's not covered under warranty, can we fix it, or did I ruin my inverter? So their responses were pretty nice. They said they would take it back to the R&D team, but most likely it can't be reverted and I'll have to replace the control board. Now I waited a couple days and didn't get a response, and I don't have a lot of time to sit here waiting months for them to research and develop a fix for this. I just said, I'll cut my losses, please give me a quote for a new control board, I'll pay it, I'll get the new board in so I can get this running back online. I paid $80 for the new control board shipped from China to the United States, and it was about 5 weeks, maybe 6 weeks I had to wait. So I took the whole inverter apart and put in the new control board, started it back up, and darn if it didn't still say V69 firmware. And now the functionality is even worse than it was before. So the control board they sent me did absolutely nothing. And they should have known what control board went with this inverter, because I specifically said it needs the V45 firmware. Here's a picture of the serial number and the date code on the side of the inverter. So at that point she wanted me to take a picture of both boards side by side and try the firmware update again, and you know, I already tried it once, it's not going to work if I try it again, so I just stopped at that point. I stopped replying and I decided to cut my losses and move on. So let's get back to the hardware versions of this inverter. We have an LV6548, no CAN, 250 volt, 65 watt of idle. We have an LV6548, yes CAN, unknown amount of idle, 250 volt charge controller. We have the LV6548V, yes CAN, 390 volt, 110 watt idle. And we may or may not have a second version of the LV6548V that does not have CAN. I don't know if that exists or not, but the statement on their website suggests it does. So what do they do now? They release more freaking inverters. They've released more versions of this. Now we have the LV6548V500, and that version has a 500 volt solar charge controller, an unknown amount of idle because I'm not about to buy one, and I assume it talks the CAN protocol. That's 5 versions of the LV6548. And by the way, at this point, I want to say towards the end of 2023, I had asked them several times and said, did you discontinue the original LV6548? And every time the answer was no. Now, a couple of days ago before filming this, I just asked again and said, did you discontinue the original LV6548? She didn't say it was discontinued, but she said it has been replaced by the LV6548V. What does that tell you? It's gone. It's done. They're done with the original LV6548s. You can see why I am so beyond fed up with this inverter. I'm just done, and I don't know why anybody else would still be buying these, knowing the other options that are available on the market, like the brand new EG4 6000 XP. I haven't turned mine on yet, but it seems like a pretty darn good inverter, and I'm excited to get them installed. So why would you continue buying these inverters? And it's sad. It's really, really sad, because these are good inverters. I really like them. I really want to like them. You know, design specifications, hardware choices, hardware support, either by them or by their upstream manufacturer, has been downright just in my opinion, this is my opinion, has been downright terrible. So now when somebody asks me why I'm replacing these inverters, I'm going to be linking to this video for the explanation. And I'm sorry the explanation is so long, but there's a long story that has to be said for you to understand kind of what I've been going through for the past year. If you're running these inverters currently, I don't necessarily think they're bad. There's nothing wrong with them. Just the way I wanted to use it with CAN bus communications back to my Batarium is just not possible. And seeing they've produced new versions, new revisions of this, in some cases haven't given it a new model number and are not providing backwards support for old versions. So in the near future here, we'll plug in one of the EG4 6000 XPs and do a little bit of testing with it. I'd like to see what the idle consumption is, and we'll go over some of the features it comes with. It comes with a lot of nice add-ons, like a DC circuit breaker for the battery input. It's got breakers for AC input, AC output, generator input, and it's got a solar PV disconnect isolator switch. So it handles both isolation and it's disconnectable. So if you've made it this far and you want to check out the EG4 6000 XPs, I'll leave a link down in the video description. It will help support this channel. Otherwise, if you've enjoyed this, please hit that like button before you go, and thanks for watching.